So let's talk about geometry. I'm going to describe you the structures of high school math. So here, the first course you are going to learn in high school for the math is Algebra 1. You may say, oh, I already learned Algebra 1. Well, that means you learned early, it's advanced. So Algebra 1 is the first math high school credit course. And then the second one is geometry. You need some Algebra 1 foundations to learn geometry. After you finish geometry, next year you will be able to learn Algebra 2. Okay. After you finish Algebra 2, it's going to be pre-calculus. From this year, pre-calculus is an AP course. Before this year, pre-calculus can have pre-AP class or regular class, but from this year, this is an AP course. That means you can take the College Board AP test to earn your college credit. After you finish pre-calculus, you will learn calculus. Calculus are both AP, but calculus has AP and BC parts. If you do the BC parts, it's going to be 1 year college credit. If you do AB, it's 0.5 credit. Okay, so we are right here. When we finish Algebra 1, we do geometry. And then we do Algebra 2. The problem is the course designed this way. So people finish our geometry and they forget everything about Algebra 1 after 1 year. And also Algebra 2, AAC itself is a very difficult course. That's why many students have big trouble for this one. So right now, let's do the foundation very well for these two courses. Geometry is a little bit different with Algebra 1. It is going to use these basic points, lines, line segment, angles, and we will deal with a lot of different relationship between these elements, and we will manipulate with algebra. So let's take a look at this. You might see this thing in your 6th or 7th grade math. So look at here. There are several different angle relationship. If we say these two, their position is the same, so we call this corresponding angle. For here, you have, if you have angle this position and that position, it is alternate and it is interior, because look at these two lines. These two angles are inside these two lines. So it's called interior, but it is not on the same side. If you see this guy and this guy, this is the same side. But if you see this guy and this guy, it's alternate side. That's why you call these two as alternate interior angle. And then maybe you see something like same side interior. This two is called same side interior. Everybody has to pay attention because I will ask you this name very quickly. Everybody will be caught. And then let's take a look at this. So for here, when you have these two kind of lines, you still call this thing same side. This is same side. It's the same position. So you call this two corresponding angle. And you say, oh, these two are not parallel. Don't worry. If these two lines like this, you could still call it corresponding angle. If these two lines are parallel, you will say, oh, this corresponding angle equal. And then for here, this is called alternate interior. And this is called same side interior. Now I'm going to ask students for those angle relationship names. Everybody has to pay attention. So, Stephen, you can unmute yourself, please. Thank you. How do you call these two guys?
Uh, the same side interior.
Excellent, very good. First, it's the same side. Second, it is inside these two lines, so it's called interior. Excellent. Now, how about number 5 and number 2?
Alternate interior.
Excellent, Stephen. Very good. How about angle 5 and angle 6? There are something.
Same side alternate.
First.
Same side exterior.
Hold on. First, these two guys are at the same position. So we call this a new name as corresponding angle. Okay?
Okay.
Does this make sense now?
Yeah, it makes sense.
Okay, pretty good. Sophie, let's take a look at 13. Look at here. These two.
Same side interior.
Good. And these two.
Also same side.
Hold down. These two. These two. Look at these two lines. If I'm talking about this angle, this is called same side interior. But the guy here is not inside. So you will see these two guys' position is the same. So we call this corresponding. Okay? Does this make sense?
Yes.
Okay. For geometry, the difficult part is not those calculation parts. So let me show you guys. You already learned algebra 1. So in algebra 1, you have those equations. You solve the equations, either one variables, one equation, or system linear equation, or quadratic equations in algebra 1. So in geometry, they give you those different relationship. You list the equation, you solve it. That's called using algebra 1 to manipulate geometry. But for geometry itself, the major part is not calculation. The major part is doing the proof. So look at here. Starting today is the first class. Starting from the third class, I will teach you guys the way to do the proof. Okay? So students who want to go to law school, you have to master this skill. This is going to train your critical thinking and logical reasonings. You have some given conditions. From those given conditions, you want to have these final conclusions. You cannot just say, okay, I think that guy is a murderer, so I send that guy to the jail. No, you cannot do that way. You have to starting from the given condition, step by step, supported by a correct reasonings. So you have to remember all of this. So I like to give students, especially our boys, a warning. Many boys cannot do geometry well, not because you don't understand. It is because you hate remembering those names. If you only show this part in your work, most teachers give you 50% of the whole points. Some teachers give you 0, no single points, because you didn't give the correct reasonings. So today we are remembering those angle relationship to serve this purpose. Okay, I will use several classes to train your guys to do this proof. It's like we are playing a hard puzzle games. So today we are going to remember all those names correctly. Make sure remember those names so that we are able to write down those supporting reasons correctly. So come back to this. Make sure you know this guy and this guy is called corresponding This guy is corresponding. If you see here and here, look at here. First thing is alternate. Second thing is within this two. So this is called alternate interior. But what will happen if you say this angle with this angle? You have these two lines. Number one is alternate. Number two, it is outside. So you call it alternate exterior. This is the time to write down the notes. This is called alternate exterior. Hold on. We have some new students, so you might not know the way I assign the homework. So here, I already see here. We have Haiti. Is this your Gmail? Okay. I will confirm with each student. Sophie, this is your Gmail. Timothy, this is your Gmail. Steven, is this your Gmail?
Oh, no.
Can you please tell me your Gmail?
It's SWEI.
This
Yeah,
one.
that one.
Okay,
Yeah.
thank you. Jeffrey,
Starts with an M.
start with M.
Okay.
M, K,
Yeah,
this
that
one? Okay, thank you.
Yes.
All right. So here, I send a email out. Please check your Gmail now to let me know if you receive the link for open the class homework and notes.
I got it.
Okay, great. You show me emoji.
I got it too.
Yeah, thank you. Show me emoji if you receive it. So during each class, here, before the class, I always upload the blank worksheet already. So you are supposed to open the blank worksheet or notes and print it out and punch the holes on the left before the class. During the class, you are welcome to write down all those important notes. For example, if you have printed out this one already, you are supposed to say, hey, this two angle is called, let me call student. Sophie, what's this two angle called?
Alternate exterior angle.
Excellent. Alternate exterior. Number one, it is alternate. Number two, it is exterior. That's it. Okay. So quick summary. Look at this. I'm going to list 5 different angle relationship inside this graph. And the names we are calling is going to be those important theorem names for our proof. In the week, starting from week 3, we will do this kind of proof. And those theorem names, starting from what we have learned today. So everybody, please pay attention. I will call every student to make sure you can know this. Jeffrey. Number 2, number 5 is called what?
Same side interior angles.
Very good, excellent. Timothy. Number 3 and number 1.
Alternate interior angles.
Very good. I'm going to write more angle names, okay? Haiti. Number 3 and number 9.
Corresponding.
Very good. Stephen. Number 9 and number 6.
Corresponding.
Hold down. Number 4, number 6, corresponding. Number 9, number 6 is called something called.
Same side interior.
Good. Same side interior angle. Very good. Next one. Stephen, you answer one more, please. Number 10 and number 9.
Alternate exterior.
Very good. Excellent. And ask you one more. 11 and number 9.
Corresponding.
Hold down. 11 and number 4 corresponding. 11, number 9. First, it is same side. Second, it is outside. So this is called same side exterior angle. Same side exterior angle. Does this make sense? See here, this two, this guy and this guy is corresponding. These two are corresponding, but here and here is called same side, but exterior. Does this make sense, Stephen?
Yeah.
Okay, so the 5 different angle relationship. Okay, now let's look at this. Look at here. This is one of the highway. This is another highway, and this is a third one. So for this graph here, you will see this guy and this guy is corresponding angle. If these two lines parallel, this angle 1 will be equals to angle 2. Okay. Now, in geometry, not only we will learn 2D, but also we will learn 3D geometry. So look at this. Look at if this way, if this is, for example, this is Highway 59, yeah? Any of us have your parents drive you on 59, yeah? So this is 59. This is a Beltway 8, and this is the Highway 610. Do you think this highway will cross with this one or not? Sophie, you think this line and this line crossing each other? Look, we have to think about the 3D. Look, when you drive on this is 59, and this is Beltway 8. One way is above the other. If we think about 2D, everyone can see my camera, right? So if you have 2 pencils in the class, we will also do hands-on activities. If you can get 2 pencils, please take it out. Take 2 pencils out. I want to see everybody is doing the hands-on activity with me together. But let's talk about the 3 different relationships between 2 lines. First, you say these 2 lines crossing, make these 2 pencils crossing. This is scenario 1, it's crossing. These 2 crossing lines has formed a plane, okay? It's a plane. And then second one, make these 2 pencils parallel to each other. Yes, everybody's doing it, good. And third scenario, we cannot only think about things in 2D, we have to think about this in 3D. In 3D, you can make the 2 pencils not parallel, not crossing. This is called a school line. Everybody say school lines. SKEW, this is the school lines, okay? Yeah, so if they design a highway in this crossing, wow, there's going to be accident every day. Yeah, they have to make these two lines going to different direction, but at two different planes. They will not crossing each other. Does this make sense? Next. Look at this figure. This is two parallel lines, and you have this line, additional line. We call this thing transverse lines, okay? And then look at this. There are how many alternate interior angles? How many pairs? Look at this question. In alternate interior, this is the first pair alternate interior. This is the second pair of alternate interior. So there are two pairs. Now, okay, Jeffrey, how many pairs of corresponding angles does this guy have?
4.
Good. This is first pair. This is the second pair. This is the third pair corresponding angle. And this is the fourth pair. So we have 4 pairs. Very good. Keep going, Jeffrey. How many alternate exterior angle? How many pairs of this? This guy?
2.
Yeah, so this is first pair. This is the second pair, so it's 2. Very good. One more, please, Jeffrey. Vertical angle. The guy here and here is vertical. The guy here
4.
and here, yes. Good job. Very good, Jeffrey. Thank you. Next one. Let's see the 3D. Oh, this is the first time. If you learned sketching, you shouldn't have trouble for this. But if you never ever learn sketching, let's draw the 3D geometry together. You have to draw on your notebook or white papers and show me in front of the camera. Everybody has to show me your drawing. So we want to draw a cube. So you first, on the top, you draw a parallelogram. If, you know, I have some student, they're either the student or their siblings can draw perfectly. I know that Jeffrey's sister can draw perfect circle, perfect ellipse, perfect square, right, Jeffrey? So go ahead, draw the, you want to draw the full, draw these 2 parallelogram and make these 2 guys similar shapes, okay? Similar size. After that, you will connect, okay? If you finish drawing, also, I want you to draw the dash line to show that those lines that you cannot see from the front, you should make it looks like a dash line, okay? When you finish this cube, you need to show me in front of your camera. Okay, good. Stephen, Timothy, Katie, let me see your drawings. Okay, thank you. So for this kind of thing, we will do the 3D geometry. For the 3D geometries, you will see even though in 2D, all you see it's simple, two lines either cross or parallel. But for 3D, you will also have school lines. So here, let's see here. CB and HG, CB and HG. So this is parallel. That's true. This is called a true-false question. And if they say ED, ED is here. ED is this line. And HG, HG is this. Some people say, well, these two lines are going to cross. No, you need to look at this 3D. This guy is on the front plane. This guy is on the back plane. These are totally on different plane. They are not going to cross and they are not parallel either. This guy is a typical school lines. Okay, so you need to answer those questions correct. So here for this page, first important thing is we learn the 5 different angles names. And second important thing is we talk about this line relationship, especially for these school lines. And we need to be able to draw 3D. We need to be able to draw this kind of figure by our hand. Many times for geometry, if you can draw it correctly, mark it correctly, you already found the solution. Now let's see, keep going. We'll answer some true, false, or always, sometimes, never. This is those typical questions in geometries. So look at this. 2 planes that do not intersect are parallel. When we do the hands activity one more time. You use your one hand as a plane. You use your second hand as another plane. So they said 2 planes that do not intersect are parallel. Well, you need to suppose that this plane is infinite. Okay, you cannot say, oh, these two are not crossing. No, these lines, this plane can go up, can go down. So they still can crossing. If I say these 2 planes that not intersect, that means no matter how you move this, they are not going to crossing with each other. So for the 2 planes, only 2 scenarios. These 2 planes either parallel or cross. Even though right now this does not cross, but it can extend infinitely. This makes sense to everyone? Next. 2 lines that lie in parallel planes are parallel. Well, I need you to have 2 pens and 2 hands together to do this game. You put the pencil in one of your hand and you put another pencil in another hand. These 2 hands are the 2 parallel planes. And you can make different scenarios. Look at this. First, you can make these 2 lines parallel, right? Or you can make these 2 lines school lines. They are not crossing, they are not parallel either. So they want to say are parallel. This is sometimes, because sometimes it's parallel, sometimes it is school line. That's why you have S. Katie, you have any question?
I had a question. So,
Yes.
So
That's very beautiful.
this
Yes.
line and the line that's diagonal from it in the 3D figure, would that be parallel
line.
or skew?
That's school line.
Okay.
That's school line.
Thank you.
Okay, thank you for asking. Next one. Yeah, if you have any question, just like Katie, unmute yourself, ask me, okay? And then let's see number 31. two lines in intersecting planes are screw lines. So how do we do this? Well, you might not be able to, actually you still can use this two hands. Yeah, you can do your two hands and you can make one pencil in one hand and another pencil in another hand. You see? You can make these two lines parallel. Yeah. You can make these two lines crossing. You can make these two lines crossing. You can also make these two lines screw lines. So here, 31, it is called sometimes. Does everybody already make the three different scenarios with your two hands and two pencils? Anybody need help? Let me know. Let me call student. Jeffrey, can you please show us how you do this with your two hands and two pencils, please? And tell us what's the relationship, please.
They're skewed because they cross each other, but they touch each other.
No, hold on. You cannot make that two hands parallel. That's already 30. We are talking about 31.
Yeah, it says
Intersecting planes.
skew.
Okay. Yes, thank you. This time is crossing. Thank you. Yeah, so you have three different scenarios, which is showing sometimes it's screw lines, sometimes it's parallel lines, sometimes it's crossings. Good job, Jeffrey. 31. Next one, 32. A line and a plane that do not intersect are screw. This is never between a plane and a line. It is either parallel or a crossing. So do this with your one hand and one pencils. Between a plane and a line, either it is parallel, or if you tilt this pencil a little bit, it is intersecting. There's no screw lines between a line and a plane. Screw lines are talking about between two lines, between a plane and a line. Either it is parallel or it is crossing, or you say intersecting. Okay, so far any question? Okay, so next, let's talk about those collinear and the coplanars. Yeah, look up. Usually for any subject, the first class shouldn't be too hard. Until you go to high school, you learn AP courses. For any AP courses, AP biology, AP chemistry, AP physics, AP calculus, even the first very beginning class is already hard. So for geometry, it is not AP level. So the first class will not be hard, but it's going to be harder soon. Let's see here. If you have 3 points on a same line, this is called collinear. This is time for you to write down these important notes. If you have 3 points are not on the same plane, same line, you connect them with a triangle. This is called coplanar. Collinear, coplanar. And then let's take a look at this. NJPQ. NJPQ. Look at your cube that you drew just now. Mark these several letters. Please mark all these 4 points on the cube that you draw just now. And then you will see, I need you also draw the dashed line for the back. So here, N, J, P, Q. These 3 points are on the front plane. This Q is on the back plane. And they ask this here. Oh, hold on. N, P, Q, R. Oh, sorry, I see the wrong one. N, P, Q, R. It's on the top plane. So it is coplanar. So you say yes. And next one, you have N, J, P, and Q. Some people say, oh, you can connect them. It's on the same plane. No, this 3 is on the front. Yeah, the very front page here. The Q is on the back. This is not in this plane. So this is called not coplanar. Any given 3 points, if it's not this collinear, then this is always coplanar. And then next one. N, M, L. They ask N, M, L. Well, these 3 points always can form a triangle. Yeah, these 3 points is not on the same line. These 3 points always can form a triangle. So it's always coplanar. So this is yes. That's how we do this one here. And next one, look at this. You want to draw this one more time. Please draw this rectangular cube. This is called a rectangular prism. Draw this guy on your paper and mark the A, B, C, D, E, F, G. Draw this thing. I need to teach you something interesting. You previously always feel curious. How do I measure these diagonal lines? I'm going to teach you how can we calculate this length quickly. Go ahead, draw this one, mark the letter. When you finish, show me in the camera, please. I always tell my students, foundation, foundation, foundation. When students go to high school, you might say, why everything becomes so hard? Well, most time it's because of your foundation is weak. Everybody finish drawing this. So you finish drawing, show me off camera, please. Thank you, Stephen. Thank you, Timothy. Thank you, Heidi. Thank you, Jeffrey. Thank you, Sophie. Good. All right. So now, look at this. You have to think about this in 3D, okay? You cannot say it in the 2D. This is 3D, so the guy inside is a dashed line. If I want to, oops. Okay, so if I want to calculate that line, how do I calculate this length value? Say, I know this is 3, I know this is 5, and I know this is 10. So how long will be here? How do we calculate this? Look at this. We learned the Pythagorean theorem, right? If you have a right triangle, this side square plus that guy square is equals to that guy square. This is Pythagorean theorem. So if you look at this bottom rectangle, this short one is 5, this longer one is 10. So the diagonal here in this bottom, this is a right triangle, here is 90 degrees. And you say, no, this is not 90 degrees. No, you need to think about this in 3D. This is 90 degrees. If you look down, this will be 90 degrees, okay? So this is 90 degrees. So that guy, a square, is 5 square plus 10 square. And then you will have here x. This guy square will be that guy square plus that guy square. So that guy square equals this. So x square will be 5 square plus 10 square plus 3 square. That's how you can get the diagonal here. That's what's going on for getting this diagonal. So here is the first formula you see here. Interesting. If you have a prism, okay, you have 3 sides, A and B and C, then the diagonal is going to be square root of A squared plus B squared plus C squared. What kind of test will ask us this question for your SAT, PSAT? Okay, you want to have this good foundation to help you apply for good colleges. Next one. Let's talk about the point outside a plane. And you see this line is within this plane. And you have a point right here. And it can go this direction. So let's talk about the relationship. So Haiti, I want you to read this question and tell me what is the answer.
What is the intersection of ST and TR?
Mm-hmm.
ST and TR.
Yes. ST is going down here. TR is going this way. They crossing at right here.
T.
Yes. Next one. One more, please. Katie, keep going.
What is the intersection of TR and plane P?
Yes. This line is within this plane. And
Yes.
their crossing is exactly this line. Make sense?
TR.
Yes.
Yes.
We use 2 points to represent a straight line. We can use one capital letter to represent a plane. Okay? One more, Katie, here.
What is the intersection of plane P and plane STQ?
Yes, STQ is here.
TQ.
Good job. Very good. Thank you. Next one. Sophie.
What is the intersection of plane P and plane STQ?
Oh, we just repeated this one, right? Yeah,
Yeah.
let's do this one next. Sorry.
What is the intersection of SQ and TR?
Mm-hmm.
Point T.
Hey, hold on. SQ is going that way. TR is going this way. These 2 lines actually is school line. There's no crossing point. You see here, go this way, this go that way. Do you think they will cross?
No.
So you say no crossing point. Okay.
Okay.
Next one. See here, go read, please.
What is the intersection of plane P and plane STR?
STR. STR here.
Um, TR.
Good. That's just TR. Makes sense.
Yeah.
Next one, 14.
What is the intersection of ST and SR?
Mhm.
No. No.
ST, the line start with S. The line start with S also. So it's S, point S. ST, SR crossed at S. Make sense?
Yeah.
Good. Next one more, please.
What is the intersection of plane P and SQ?
Plane P and SQ. SQ will go down here, right?
SQ.
SQ is going down here. It crossing with the plane at point Q. So point Q, that's the answer. Does this make sense?
Yes.
Yeah, maybe because the first time we see this, we feel confused. After we do this, we will feel way more better. Now let's check the coplanar and the collinear. Any 2 point, you use a single letter, capital letter, represent a point. You can also use a P. If you say plane P, that point is also can represent the plane. You use 2 capital letters to represent a line. Now we will answer those collinear questions, okay? Timothy, do you think T and R collinear?
Yeah.
Good. How about SQ?
Yeah.
Very good. How about, look at this, S, T, R. Do you think it's collinear?
No.
Good job, Timothy. You improved a lot in this summer. Thank you. Next one, let's look at this coplanar. Coplanar is another big thing for today. So let's see here. Stephen. Let's do this. SQR.
Yes.
Good. STR.
Number 22 or 20.
This is also using the same graph.
Wait, like number 20?
Yes, number 20.
Yes.
Coplanar. Very good. How about STRQ?
Yes, it is.
Hold on. Let's do this carefully. ST is here. STR is this plane. Q is this guy. You think this guy is in this plane?
No.
No, so here is no. Make sense? Does that make sense?
Yeah, it makes sense.
So for SQR, yes. For STR is yes. But for STRQ, this is a triangle, it's the same plane, but the Q is outside. So this is not coplanar. Okay? Next one. Let's see, Jeffrey. Let's see here. ST and R is coplanar.
No.
Yes.
No,
Yes. It's this one is yes. And then ST and Q.
Yes.
Good job. That's yes. And then ST, oops. Something wrong here. Okay. All right, fixed. Uh-oh. You know, because they updated these apps, I think they made some bugs that they didn't fix. That's why sometimes it's not clearly. So first STR is a coplanar. Second STQ is a coplanar. And next one is ST and TR. ST and TR. What do you think, Jeffrey?
Yes.
Good. Because it's a crossing. If it's a school line, it is not, right? Next one. Timothy. Let's do a few more, please. Look at here. TR and S. TR and S is coplanar.
Yeah.
TR and a Q.
Yeah.
Good. TR and SQ. Be careful.
No.
Good job. Very good. Thank you. No, it is school line, so it's not in the same plane, right? Next, maybe do something a little bit advanced. So if we have students who want to prepare those AMC 8, you might want to know how do you prove the Pythagorean theorem. Even though you will say, if I have a right triangle, this side is B, this side is A, then this guy is going to be C squared as A squared plus B squared. This is Pythagorean theorem. But why? Why you think this is true? How do you know this is true? So here, with algebra, we can prove. So look at this. You can first, you need to draw this. First, draw this graph. You need to draw the full chasing identical right triangles like this. Go ahead, draw this. Draw this on your paper. You want to draw this four identical right triangles chasing each other, head to tail, chasing each other rotationally like this. As long as you get this formal training with me for geometry, you build up good solid foundations. By the time you start pre-calculus, you will not feel so scared. You want to draw this? Anybody finish drawing this? Good, Timothy, thank you. Jeffrey, good job. Katie, good job. Steven, good job. Sophie, good job. Yes. So after drawing this, I want you to mark the outside to be C. And what you want to mark here, this is the short one, which is B, short one B, short one is B, short one is B. So the right triangle has two legs. The short leg is B, the long leg is A. The longest side, which is the hypotenuse, is C. And then look at this. Sophie, the B and A, this is 90 degrees. So what's this triangle area?
Wait, can you say that again?
This is B, this is A, this is 90 degrees. How much is this area?
Oh, 1/2. 1/2 base times height.
Yes, 1/2 AB, correct?
Yeah.
So this triangle area is this. And you have 1, 2, 3, 4. You have 4 of this, correct?
Yeah.
And then look at here. This longer one is A. This shorter one is B. So you will use this guy minus this guy. So this guy is A minus B. Makes sense?
Yeah.
Same thing for here. This longer one is A. This short part is B. So this part is A minus B. You have this here also A minus B, A minus B. So the inside here is a perfect square. The perfect square area should be how much?
A minus B.
Parenthesis square, correct?
Yeah.
Do you remember this formula? Who is this guy? X squared
X squared
minus
minus 2.
2xy plus y squared, correct?
Yeah.
So with this formula, you will plug in this formula right here. Look at this. 4 times 1/2 AB is 2AB. And here is A squared minus 2AB plus B squared equals to C squared. This 4 area plus this equals this total big square area, which is C squared. So these two canceled, so you have here. Make sense?
Yeah.
That's how we prove the Pythagorean theorem. Go ahead quickly, write down these notes. This is first time you can prove. Oh, you can prove Pythagorean theorem. That's pretty cool. You know, back to thousands of years ago, only the greatest mathematician can prove this. Now you can prove this. You become a mathematician who can prove this. That's cool, right? Yeah. We not only want to remember those theorems, but also we know where the theorem or formula come from. That's where this come from. Yeah, if you haven't read down all the notes, I post this on the Google Drive so that you can access after the class. Next, I do give something, so I do put all the work and with my detailed solutions. So you need to look at all my notes after the class. Now let's talk about something. We will review the point, the line segment, the screw lines, and the plane and the coplanars all here. You always use 3 uppercase letters or 1 uppercase letter to represent a plane. You can use a lowercase letter to represent a line. This is the typical ways in geometry. So here, say, you can use a lowercase n to represent this line, lowercase t to represent this line, lowercase l to represent this line, okay? Now look at here. They ask you another names for plane D. The plane D is showing right here. And you want to give another name. So you can see this guy has who? It has capital P, capital B, capital H. You see here, this guy here. You can say P, B, E, the 3 letters represent this plane. Or you can say B, E, H to represent this plane. Okay, 1 capital letter or 3 capital letters to represent the same plane. And next, Timothy, for the plane P is this plane. And hold on, sorry. this line, and this line. You use two lowercase here to represent these two lines. What is the crossing point? It's right here. Okay.
Yeah.
Mm.
B.
Yeah, we would like to be able to draw. Look, you can use a lowercase to represent the line. At the same time, you can use two capital letters to represent the same line. You can also use three capital letters to represent a plane. It's all fine. Okay. And then look at this here. They ask you another names for line T. Line T, you can also call this capital BE, line BE. Two capital letters, all one lowercase, to represent a straight line. Next, intersection between plane C, which is this, and a plane D, which is this. So two planes meeting together at a line. This is line T. That's it. Okay. Next. Any questions so far? Please ask me. Now, we are going to call students to answer those questions inside this. This one is not a perpendicular one. It's tilted a little bit, but it is still 3D geometry. So let me call Jeffrey. Can you tell me two examples inside this graph for number 7, please?
Wait, can you repeat the question?
Can you tell me number 7 examples inside this graph?
HF.
A, B, and HF. Very good. That's a very good example. A, B, and HF. Can you give me one more example, please?
CD and GE.
C, D, and G. Very good. Thank you. One more. You answer one more question.
AB and EF.
A, B, and E, F. Very good. Who else? Who else?
AB and CD.
Yes. See, AB, CD parallel. AB, GH parallel. AB and EF also parallel, right? Yes. In the future, look. In the future, when we say we are going to do the proof very soon, if you say AB parallel to CD, and you say CD parallel to EF, then you will have the conclusion of saying AB parallel to EF. You call this transitive property. Please write down these important notes. You will use this kind of thing very soon. Okay. Next, let me call Steven.
Number 9.
Mhm.
CD and HF.
CD and HF. Very good. Number 10.
GH and EF.
DH,
No, G.
GH, EF.
Yeah.
And you see these 4 lines are actually all parallel to each other. Okay? That makes sense.
Yeah.
Okay, thank you. Next one. We will do those always, sometimes, never questions. Sophie, Let's go ahead. What do you think?
Two lines that do not intersect are sometimes parallel.
Yeah, because it could also be screw lines, right? Rays. Lines means it's going to both direction infinitely. Rays is starting from this point, go one direction. Go ahead, Sophie.
Two rays that share an endpoint are sometimes.
Yeah, see here, this guy and this ray are not opposite. It's sometimes. Number 13.
Two lines parallel to the same plane are sometimes skew.
Yeah, you have the plane here. You can make these two lines crossing. You can make these two lines parallel. You can make these two lines screw line. Yeah, so this is S. All of them are sometimes. Make sense? This one is not complete question. Don't worry. You can ignore those questions. And then let's see here. Haiti. Go ahead.
Hold on. Intersecting lines are
Do your two fingers. If the two lines intersecting, it is what?
always.
Yes, good job. It's always. Okay. Now, next one.
Skew lines are never.
Yes. Yeah. If the school line will intersecting each other, we will have a car accident every day, right? Yeah. Number 17.
In space, two lines perpendicular to the same line are in space. Two lines.
Sometimes, never, always.
Two lines perpendicular to the same line.
Do your finger game. Do your finger game.
Never.
And really? What do you think this?
Perpendicular to the same line. Oh, sometimes.
Yes. Students, when you do this, sometimes never, always questions, you manipulate with your hands and pencils, you will be able to get the perfect answer. Okay? Next one. Timothy, let's do this. Go ahead, number 18.
All right, two planes, never.
Good job. Two planes either overlap or crossing with one line. So this is never. Thank you. How about next one?
A plane containing 2 points of a line.
Contains the entire line.
Uh,
Do your finger with a pencil. Answer this question correct.
sometimes.
Okay. 2 point decide a line. If this point, 2 points is already in this plane, this whole line is contained in the plane. Always.
Oh,
That makes sense?
yeah.
Yeah, do this with your finger, with a pencil. Think about it. Does that make sense?
Yeah.
Okay. Next. Jeffrey. Go ahead.
4 points are sometimes
Good job.
coplanar,
Sometimes coplanar, sometimes what?
sometimes not coplanar.
For example, you have the 3 points on this plane, but you have another point outside, right?
Yes.
How about 21?
Two lines sometimes meet in more than one point.
Good job. Good job. Number 22.
Two parallel lines are always.
Good job. Always, always. Thank you. Next one. Stephen. How about 23?
It's never.
Good job. How about 24?
Always.
Yes, good job. Very good. Thank you. This is never, this is always. And then let's see here. Sophie, 26.
Two planes that do not intersect are sometimes parallel.
Do your finger games and correct this, please. For two planes, it's either parallel or crossing, right?
Yeah.
If they do not intersect, it's going to be always parallel, correct?
Yeah.
Okay, next one.
Two lines that lie in parallel planes are sometimes parallel.
Sometimes parallel, sometimes,
Skew.
sometimes. That's all. They will not crossing. Yeah, it's in two different planes. Next one.
Two lines in intersecting planes are sometimes skew.
Good. That's it. Okay. Yeah, I do see that all students here are really paying attention and do very great job. I'm proud of all of you today. And let's see here. This is a new sign. This is called the belong. Okay. If you see this direction, the left side will belong to this right side. Just something similar like this. So the smaller parts belongs to these bigger parts. This is called belong. So for example, here, line segment DE belongs to line segment DF. So you can have this. Or you can say line EF belongs to DG. Or you see FG belongs to DG. This is called belong. And next, this is called or. You can also see this as union. This is or this is union. So if you say DE or EF, DE or EF is going to equals to DF. If you say DF or EG, you cannot say this is not doing the plus or minus. It's just doing the logic operation. So the DF parts or the EG parts, this is corresponding to DG parts. So this is DG. Okay. This is called union. Another guy, if you flip this upside down, this is not union. This is called and. This is called and. What does and mean? And means this. Say DF and EG. DF is here, EG is here. This is equals to EF. Because you want to make the DF parts happy and make the EG parts happy. So you will have the guy between them. It's and. So far, any question? Any question so far? No question. Now we are going to use, okay, let me do this. Look at this question. This is a tricky question because it has 3 different scenarios, A, B, C. They told you, oh, I have 3 points, which is collinear. All right, collinear means it's on the same line. And you have the AC, which is 24. And you have 1/3 of AB equals to BC. And they ask you each parts, how long is it? So you don't know the B location, right? They only tell you this, but without graphing it. So you have to draw it by yourself. You say, okay, first scenario is B is between. So you will put B is between, and you have the total length as 24. 1/3 of AB equals to BC. So you call this piece as X. This total as 24. The rest of them is 24 minus X. You have also know that 1/3 of AB is equals to BC. So you do 1/3 of AB. 1/3 of AB is equals to BC. So you have 1/3 of AB, which is 1/3 X, equals to BC. BC is 24 minus X. So you have that equation and you solve it for your X. This is scenario A. And then you will do the scenario B. So this is scenario B. So here, let me text y'all guys my phone number. I want y'all guys to be able to do this on your sketch paper. If you have iPhone, iPad, you can use your iPhone, iPad to send me a message to this number. I send this number to everyone. So please, I'm going to hide my work. I will hide my equation, but I still do you a favor by showing you the graph and the given conditions. I said this already. For geometry, if you can draw the graph and mark it correctly, you'll find your solution. Go ahead, draw this scenario A, scenario B, and scenario C. And then go ahead, list your equation based on the given condition. When you finish, take a picture or scan it, whatever is faster for you. Send me by iMessage. If you don't have a phone, ask your mom for a phone, okay? Don't feel sad to say, my parents still didn't give me a phone. Sometimes without a phone may be a blessing because it helps you deal with those noise, you know? But if you need additional help, say, teacher, can you walk me through scenario A or scenario C or scenario B? Just unmute yourself. I will walk through with you together.
Do we do question A?
I want you to do scenario A first, and then do scenario B, and then do scenario C. For question 36 right now, the equation is the simplest one, which is one variable equation, first order. And if they make the question a little bit tricky, it's going to be like quadratic equations, or sometimes you need to solve system linear equations. Very good, Timothy. When you send me your work, you have to show me your graph. You cannot only show me your equation. For any geometry questions, if there is no graphing showing, it's not complete.
I don't get how to do B.
Okay, thanks for asking me. So let's do it together. For scenario B, which we say, okay, C is between A and B. Yeah, so if you draw the A and B, and between them, it's going to be point C. And look at here. AC is 24, right? And then we don't know this piece. We write down X. We don't know, it's okay. We list it as X. And then we want to use this given condition. 1/3 of AB. Now, how much is AB now, Timothy? If this is 24, this is X, how much is AB? AB will be 24 plus X, correct? Timothy.
Yeah.
So 1/3 of AB, we don't know, but it is 24 plus X, correct?
Yeah.
BC, how much is BC?
BC is
X.
X.
So you put this guy as X. And both sides you can times 3. So you do 24 plus X equals to 3X. So 2X will be 24. X is 12. Make sense now? Correct? Timothy, did I
Yeah.
answer your question? Okay. And then you can also draw the graph for scenario C. You will see A is between. So you do put B and C, but between is A. And then you don't know how much is here. You call this X. And here AC is 24, so you mark here as 24. 1/3 AB. 1/3 AB is X, so 1/3 X equals to BC. BC will be X plus 24. And then you times 3 for each side. And when you finish this, you will have a negative. You will see how come I have a negative. Well, that means this scenario doesn't exist. You don't have this scenario. If you calculate the line segment is a negative, that means that scenario doesn't exist. So let me see students' work. Very good, Stephen. I really like your job. You have very clean and clear graph, marked correctly, correspondingly, and your calculation is perfect. Thank you, Stephen. Other students, please send me your work.
Can I send it through Gmail?
Sure, you can also send by Gmail. You can also send by WeChat. Doesn't matter which way you use, okay? Let me say about the way you do the homework. So the folder, I suppose everybody already know how you can access the homework. So each week You will not receive a new email. It's the same email. You just open it and you refresh the link. Then you will automatically receive the homework. So what I do, see here, I upload. So 02 is uploaded, but of course I will not show you my work. So the blank version is given. And when you open your homework link, when you refresh, you are supposed to see the 02 already. For 01, this is for today's homework. You need to finish, you need to print out this blank one and print it out and do it on this paper. On everything I listed in the Google link, and then you need to open, download, and do it. I will upload my notes right after the class. If you have questions, if you feel confused, you can look at my notes to finish your work. And then you need to send me to my Gmail. The Gmail I send out the link is the Gmail for sending your homework. Reply my email so that you can send me your homework. Okay? Before the next class, you need to turn in my homework. Before the next class. Anybody else finish the homework? Finish the question? Yes, Sophie? Yes, you have every step correct. Perfect. Thank you. Who else? See this one, 36, they have 3 different scenarios and you solve each of them and you say, oh, B is possible, C is possible. A is possible, B is possible, C is not possible. And then when you keep going down, I have one example here. This one, you don't have 3 scenarios. They already ask you to put the IL, see here, this is PI, this is IG. And you need to use this guy plus this guy equals this total. So this total is Ix squared equals the left part plus the right part. And then you will see your old friend of algebra 1. In this algebra 1, this is quadratic equation. You need to solve it. And then you will be able to find out this piece length and that piece length. Let me see. So Timothy.
Go back. Yeah.
Yeah, what's your question?
Wait, can you go back?
Here?
Yeah.
Okay. I will upload all these notes. You can write down this after the class. So I'm going to let me upload all my notes. This is today's notes is uploaded. And you guys need to finish the homework. Oh, by the way, before you guys leave, if you have already been out for vacation, send me say, I have already been to Disney World or China or Japan or somewhere. If you have never take any break, also send me, let me know, okay? I do like to know that if you already take your summer break or not. Send me a message in Zoom. Tell me, share me privately saying, oh, I have already been traveling to somewhere or some places. If for this whole summer you haven't been traveled for anywhere, you can also let me know. I will have sympathy and empathy to you. Okay, so this is the first class, and I will see you guys on Sunday afternoon, which will be our second class. Right after each class, you need to finish your homework, send me by Gmail. And if you have a question, if you have concerns or some things, you are welcome to send me an email. And I always send out the link. For some reason you have troubles for understanding my teaching, you can look at the videos to make sure you are able to see something in the video can make you clear. If you still not feel clear, you can send me email. That's for today's class. Answer my question if you have already been traveled to somewhere. If you answer that question, you can leave. Thank you, everyone. I see you on Sunday afternoon.